Short notes on construction materials. In this video, we will be seeing the topic related to bricks. Bricks. It contains alumina of 20 to 30 percentage, silica of 50 to 60 percentage, lime. Lime helps to prevent shrinkage, and oxides of lime are present in 5 to 6 percentage. It provides a red color to the brick, and it also contains magnesia, which provides yellow tint. Next, the sizes of the bricks are standard size 19 cross 9 cross 9 centimeter and nominal size is 20 cross 10 cross 10 centimeter. And the classification of bricks. Bricks are classed as class 1, 2 and 3. For class 1, the water absorption should not be greater than 20 percentage and the strength should not be less than 10 Newton per mm squared. For class 2, the water absorption should not exceed 22.5 percentage and the strength should not be less than 7.5 Newton per mm squared. For class 3, the water absorption should not exceed 25 percentage, beyond which it would not be strong and it will fail to be a brick. And the strength should not be less than 3.5 Newton per mm squared. And test for bricks. The basic test for bricks are water absorption. You take a bond, you immerse immerse the brick in the water and then evaluate the water absorption. And crushing strength is similar to that of how you test your cube. Similarly, you're going to test your brick. And next is your hardness. You take like you scratch the surface of the brick with either a nail or with any other sharp particles. And efflorescence, it is the evaluation of the presence of any white patches, etc. And next is wrapping. Wrapping is nothing but the greatest distance from the edge to the center, like where it behave either in the concave or convex direction. And next is soundness test. So we'll see what if the composition contents increases and the corresponding effects. So if the silica content increases, it destroys the cohesion in the bricks. Similarly, when alumina contents increases, the bricks tends to shrink and wrap. If the lime content increases, what will happen is the melting point will be dropped and it will lose the shape of the brick. If iron oxide content increases, then dark spots, which will be dark blue or black color spots, will be appearing. If the magnesia content increases, the bricks will be tending to decay. So next topic is manufacturing of bricks. For the manufacturing of bricks, we have 4 different processes. The first process is preparation of the clay, next is molding, next is drying the brick, and then you burn it finally to get the final version of their brick. So for the preparation of the clay, first is unsoiling. Unsoiling is nothing but you cut the top 20 centimeter of your earth surface and then you dig the soil. You collect the soil, you then clean it and then you weather it and you blend it. Finally you temper in order to obtain the clay which is required for brick manufacturing. Next is molding. Molding can be either done by hand or by machine. If you do it in hand, you can do it in 2 different types, either by ground molded or you can use use table molding. Next is drying. Like once after this molding is done, you need to dry it. Only then you will be able to prepare your bricks. So what we do is we reduce the moisture content to 2% by natural drying at sun drying. That's not, natural drying is nothing but sun drying. After sun drying, what we do is we have to burn our bricks. Only then we'll be able to get the required strength. So we burn at 1100 degrees Celsius. What will happen if you burn at 1100 degrees Celsius? The particles will get fused and it will be bonded together. That will give you good strength. Increase the strength content. This burning process can be done in 2 places. One is in your clamps or in your kilns. Based upon the size of your production. If you're doing small scale production, you can do it in your clamps. If you're going for large scale production, you need huge number of bricks to be manufactured, then you do it in your kilns. So next you have certain 2 parameters, that's nothing but pugging. We'll see what are those. Pugging is nothing but grinding clay and water. that will be in the plastic state, and that you call it as pugging. Next is kneading. What is meant by kneading? It is nothing but the process of mixing the clay with water and other ingredients. This is called kneading. This they'll be asking in the objective types, so I don't want to miss out those points, and that I have mentioned it here. And next is harmful ingredients of your bricks. What are the harmful ingredients? It's nothing but what will happen if your compositions or other ingredients are applied in excess, or they're offered in excess. So if the lime content increases, unsoundness will be there. If your iron pyrites increases, it will crystallize and disintegrate your bricks. It will break your brick. If the alkali content increases, then it will absorb moisture and that will deposit on the walls. You can observe some moisture content present in your walls. And if the pebble content increases, it does not allow the clay to mix properly. There will be improper mixing or blending. If the organic matter increases, then the brick content will become more porous. What will happen if it becomes more porous? Then it will absorb more water and it will not give you proper strength or the required strength. So we'll be seeing about types of bonds. So types of bonds, I have listed only the 4 basic types of bonds. So first is your header bond. Header bond is nothing but the shorter side of your brick, that is your header bond, and the one which you see in your longitudinal axis, the stretched one, that's your stretcher bond. So it's nothing but continuous placement of headers over next to each other and over row size also, that is called your header bond. Next is stretcher bond, continuous placement of your stretcher bonds of your bricks, and that could be followed in the row wise. So this is your stretcher bond. Third one is your English bond. English bond is nothing but placement of continuous row of header bonds, and it is followed by an alternative placement of row of stretcher bonds. So it will be like stretcher header followed by stretcher header, and it goes on. So next is Flemish bond. Flemish bond is nothing but alternative placement of header bond and stretcher bond, header bond and stretcher bond. So similarly, in each row you place it as alternative placement of H, HS, HS. So it will, in the next row it will be like here it will be SH, SH. That's nothing but stretcher header followed by stretcher header. So in most of your competitive examinations and your interviews, you will be asked what is meant by English bond and Flemish bond. So this is nothing but the simple difference. So you just remember this diagram and it will help you to answer all your objective or your interview questions. And next is based upon the strength. We can tell that English bond is always greater than Flemish bond. In the aspect of appearance, Flemish bond is always better than your English bond. So next is, so we have seen that we'll be burning the bricks in order to obtain good strength. So while burning, we can be either using your clamps for your small scale production or your kiln for your large scale production. So this kiln is of 2 types. One is Bull's Trench kiln and another is Hoffman's kiln. So 2 types are there. So we'll see what are the different parameters and which will be suitable for which condition. Here, burning capacity is the first parameter. You can burn up to 2.5 to 3.5 lakhs bricks in 2 weeks. Here it goes for 40 lakhs per season. And the work, you have to stop the work in the monsoon season as you do not have any roof over it. But in case of Hoffman, you can use it in all 365 days because you have a permanent roof over your kiln. So if it rains also, you can do your brick production. And cost of fuel, it increases here but it decreases in a Hoffman. The popularity wise, Bull Trench is more popular because the initial cost is very less. The Hoffman, the popularity is less because the initial cost will be huge because you need to construct a permanent roof to protect your manufacturing process from rain or from other wind conditions. Next is percentage of good quality bricks. The percentage of good quality bricks is very low in case of Bull Trench, but the quality is high in case of Hoffman production.